Hello people, so in this video we will be discussing about numerical Python U functions, and in this video we will be discussing products, differences, how we can find LCM and how we can find the greatest common divisor or the GCD. Okay, so without wasting further time, let's get to the coding part. So for finding out the product, we will have to use the function prod opening and closing bracket, which is nothing but p. Okay, so I'll just write it and show it to you. So it is something like prod opening and closing bracket, which stands for product. Okay, so for using it, first we will have to import the numpy as np. So let's do that first. So import numpy as np. Okay, and in the next line we will be creating an array as we do. So array is equal to np dot array, and inside let me add few bunch of numbers or elements. So let's say that I'm taking 1 2 3 4. All right, now for finding out the product, what we will be doing is we will be writing x is equal to np dot prod and inside arr. Okay, so let's write it. X is equal to np dot prod or prod and inside arr. Okay, we do not want this indentation. I don't know why this is happening. Okay, so we do not want this. So x is equal to np dot prod and inside arr, and now we will be printing. So print x, shift and enter. So we are getting 24. Okay, we are getting 24. All right, so now moving on. Okay, so let me just make this clear why we are getting 24. So 24 because 1 into 2 into 3 into 4. So all the numbers inside my array is basically getting multiplied. So 1 into 2 is 2, 2 3s are 6, and 6 4s are 24, which we are getting as the output. Okay, so now if I want to find the product of the elements of two arrays, then we can do it. So let me write. First I will be creating two arrays, obviously. So array 1 is equal to np dot array, and I'll be writing 1 comma 2 comma 3 comma 4, and in the second array I'll be writing array 2 is equal to np dot array, let's say 5 6 7 and 8. Okay, so let's take these numbers 5 6 7 8. All right, now I want to find the product of these two arrays. So for finding out the product of these two arrays, I'll write x is equal to np dot prod and inside array 1 comma array 2. Okay, all right, now I'll be printing this. I could have just combined the product statement and the printing statement together, but just to make the lines of code look neat, I'm doing separately. So print x, shift and enter, and we have got this. Okay, so 40320 because 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8. Okay, so this is basically the product of the two arrays, which is 40320. Okay, moving on. Now we can also find the product over axis. So we have already performed the summation over axis, and now we will be using axis is equal to 1 for finding out the product over an axis. Okay, so if we specify axis is equal to 1, numpy will return the product of each array. Okay, so let's write it. So I'm using the same array, array 1 and array 2. So I'm just copy pasting it in this cell. Even without copy pasting, we can use it. We can access these two arrays, but I'm just writing it so that the overall program looks neater. All right. So these are my two arrays, array 1 and array 2. And now I'm writing new array is equal to np dot prod, and inside I'm writing array 1 comma array 2, but this time I'll also be mentioning the axis. So axis is equal to 1. Okay, So if I write axis is equal to 1, numpy will return the product of each array. Instead of combining both of them, numpy will return the product of each array. Okay, so moving on, if I write the printing statement, print, shift and enter. So 1 into 2 into 3 into 4 is 24, and 5 into 6 into 7 into 8 is 1680. Okay. Alright. So we can also find the cumulative product. So cumulative product means taking the product partially. For example, the partial product of 1, 2, 3, 4 is 1, 1 into 2, 1 into 2 into 3, 1 into 2 into 3 into 4. So we are basically getting 1, 2, 6 and 24. Okay, so we can also find out the cumulative product. So let us take a different array and I'll write the lines of code and I'll show it to you so it will become more clearer. Okay, so let's say that I want to take a new array. Okay, I want to take a new array. ARR is equal to np dot array. All right, and inside I'll take a bunch of elements 5, 6, 7, 8. Let's say 7, 8. All right, I've taken in a bunch of elements and I want to find the cumulative product of these elements. So new array is equal to np dot cumprod. Okay, and inside arr, and now we'll be printing this. So print new rr, shift and enter. Okay, so what is happening? We are getting 530, 210 and 1680. Okay, so this basically means that the first element is printed as it is. Okay, the second element 6, it is printed. So basically what is happening is 6 into 5 for the second element. For the third element 210, we are basically doing 7 into 6 into 5. So we are getting 210. And for the fourth element, that is 8, we are doing 8 into 7 into 6 into 5, and so we are getting 1680. Alright, so this is what the cumulative product was. Okay, now moving on, we go to the numpy differences. Okay, up till here we discussed about the numpy products. Now moving on, we go on to the numpy differences. So for calculating the difference, we will simply write np.diff, diff, and inside we will write the array. Okay, so let's say that the discrete difference means subtracting two successive elements. For example, if I have a single dimensional array and inside the numbers are 1, 2, 3 and 4. Okay, so the discrete difference would be 2 minus 1, then 3 minus 2, then 4 minus 3. So the next element minus the previous element. Okay, the next element minus the previous element. So that is what the diff function gives us. So it might sound a little confusing, but let's do the coding part and you will understand it better. Okay, so let's say that I want to take an array. Array is equal to np dot array inside 10, 15, 25, 5. Okay, and new array is equal to np dot difference function we are using, so diff, and inside arr. Okay, now we will be printing this, so print, shift and enter, and we are getting 5, 10 and minus 20. Okay, we are getting 5, 10 and minus 20. So for the first element we are getting 5 because it is happening, 15 minus 10 is happening over here. So 15 minus 10 gives us 5 for the first element. Okay, then for the second element 25 minus 15 gives us the result second element, that is 10, and 5 minus 25 gives us minus 20, which can be seen over here. Okay, all right, so this is what the difference method in universal function does. It gives us the discrete differences. Okay, All right, moving on. Now we will be discussing about the LCM and the greatest common divisor. Okay, we will be discussing about the LCM and the greatest common divisor. So LCM is the lowest common multiple, as we all know. So the lowest common multiple is the least number that is common multiple of both the numbers. So we have already imported numpy as NP. So let's say that I have got two numbers, number 1 and number 2. So my number 1 is 4 and number 2 is 6. So number 1 is equal to, let's say, 4 and number 2 is equal to 6. Okay, all right. Now I want to find my LCM, or the lowest common multiple. So for finding out the LCM, we will write x is equal to np dot LCM, and inside number 1 comma number 2. Okay, all right. Now I will be printing x. So print x, shift and enter, and we got 12. Okay, it returns 12 because that is the lowest common multiple of both the numbers. Okay, 4 into 3 is 12 and 6 into 2 is 12. That is the lowest common multiple of both the numbers. Alright. We can also find LCM in arrays. To find the lowest common multiple of all the values in an array, we can use the reduce method. Okay, so the reduce method will use the universal function, in this case the LCM function, on each element and reduce the array by one dimension. Okay, so for finding out the LCM of the values of a certain array, so let's say that first let me specify the array. First let me add some cells. Okay, so let's say that I'm taking an array is equal to np dot array, and inside specifying some values, for example 3, 6 and 9. Okay, all right. Now I'm writing x is equal to np dot LCM dot reduce, and inside I'll be writing ARR. Okay, so let's see that what is this line of code gives us. So I'll be writing x is equal to np dot LCM. Okay, and now I'll be writing dot reduce. Okay, and inside ARR. Okay, let's print x and see what we get. So printing x, shift and enter, we get 18. Okay, why 18? Because 18 is the lowest common multiple of all the three numbers. Okay, of all the three numbers, 3, 6 and 9. Since 3 into 6 is 18, 6 into 3 is 18 and 9 into 2 is 18. So we are getting 18 because it is the lowest common multiple of all the three numbers. Okay, you just write 3, 6 and 9 in your copy and just try to find out the LCM. You will be getting 18 as the answer. Okay, alright. Now moving on to the greatest common divisor. So let's say that I want to find the greatest common divisor of two numbers, number 1 and number 2. So I'll be just writing, let's say number 1 is equal to 6 and number 2 is equal to 9. X is equal to, randomly I've taken two numbers 6 and 9. X is equal to np dot GCD, and inside number 1 comma number 2. Okay, x is equal to np dot GCD, number 1 comma number 2. Now let's print this. So print inside x, shift and enter. So we are getting 3. It returns 3 because that is the highest number. Both numbers can be divided by 3. 6 can be divided by 3, we get 2, and 9 can be divided by 3, we get 3. So 3 is the number. It is the highest number both numbers can be divided with. Okay, so this is it for this video. In this universal function numpy video, we learnt about how to find the product, how to find the differences, how to find the LCM, and how to find the greatest common divisor. And in the next video, we will be starting off with the scientific Python or the SciPy, which is a very important library in Python. So you can watch the entire series of NumPy which I have made, and in the next series we'll be discussing about the SciPy or the scientific Python. So thank you for continuing, and we'll together meet in the next video. Thank you.